Assalamualaikum warahmatullahi wabarakatuh. My name is Omar Abu Hassan. Now let's continue the second part of boost converter.
Right. So this one is for relation between V out and VS. Then we have to look into um, our how to calculate the inductor current, and also how to determine the inductor value. Because whenever you want to design our boost converter, we have to decide uh, uh, type of switch that we want to use. That depend on our power requirement, our current in our boost converter, and then type of application that we want to use, how many frequency, how much frequency that we want to use. eh. So that one we need to decide when we design our boost converter lah. Okay. Okay. So this is the one that I mentioned before. And okay. Okay. So for to determine the inductor current, eh, input power, usually the output power is the same as the input, right? So we cannot increase uh, the power that you transfer from the input. That is the power that we get in the output uh, plus losses lah. So we can determine our uh, inductor current based on this model. So input power is Vs times with Is, while for the output power is equal is V out square over divide by the resistor lah, ataupun load or load. So V out we can replace with this model. This one we get from the previous that V out model lah. So from that we can get this. Then when we if we move this Vs into the to the left side, we will get this model. So IL is equal to Vs over 1 minus D squared times with R. Times with R. Okay. So basically we need this model in order to determine the value of current that passing through the inductor. Not just in the inductor, but basically current that will passes through the our switch and the diode, because we have to make sure that our diode, our switches is capable of handling this value of current. Otherwise awak bila awak design, kalau awak punya switch or diode awak cannot handle the level of current that circulate in your circuit, then your diode ataupun your switches will be burn. So kita tak nak macam tu lah kan. Okay. So this model is to calculate the inductor current. Then after that we can also determine from the ripple current, charging and discharging process, we can determine our inductor, minimum value of inductor from IMIL. So the ripple current, inductor ripple current, so we can determine from Imax minus Imin. Delta IL is equals to Imax minus Imin. So from that we can replace, and we know that delta IL is equals to Vs times with dt over L. So then we can replace. So kita boleh letak kat sini. So let's say for Imax is IL plus delta IL over 2, divide, kita divide by 2 lah, separuh. Maknanya because IL is in the middle between ripple lah. So kalau kita ada ripple macam ni, if we have the ripple current like this, and the top one is Imax, the bottom one is Imin, and this one is min, this is max, and the The delta IL is the difference between Imax and Imin. So our inductor current is sitting in the middle, IL. This is IL. Yeah. So this is IL. So that's mean we can determine the Imax. So Imax is equals to IL plus this one, this length. So that's mean delta IL divided by 2 lah. Delta IL divided by 2. So IL plus delta IL divided by 2. The one is for Imax. For Imin, the bottom one is IL minus with delta IL divided by 2. This model. Yeah. So if we replace both of these function with this one and this one, then we get our model for the Imin and Imax lah. So for Imin, we can use that model to determine our inductor, minimum inductor value. So this is the minimum inductor value, Lmin, but the value for the inductor must be 5 times or 10 times Lmin. Yeah? So this is the model for the Lmin. So Lmin is the minimum value of the inductor. So whenever you design the boost converter, start with the specification and then finding the value of duty cycle, inductor current, and then maximum ripple for the current Imin and Imax, and then from Imin you can determine your Lmin. Lmin. Okay, then we also need to determine the ripple factor. Ripple factor means for the output lah, for to determine the capacitor value. So we use this model. Yeah. So ripple factor R is equals to delta V out. Delta V out is the V out basically over delta V out over V out. This means if we have our okay, let's say we have like this, our V out. Okay. So delta V out is the V out maximum and V out minimum. So that one is the delta V out. Delta V out. Okay. And basically V out is in the middle. V out is in the middle. So the ripple factor is delta V out divided by V out, and that one is equals to D over RCF. D is duty cycle, R is the load resistor, and C is the capacitor that you want to determine, and F is the frequency of your system, of your boost converter. Okay,